So we do the magnifying power of a simple microscope. A simple microscope is a convex lens. So let's say this is our principal axis. And let's say these are the two foci. So if your image is here, if the object is here, a ray of light parallel to the principal axis will pass through the focus, and it can be reproduced backwards, and the ray passing through the optical center will travel without any deviation. So let me just do that again. So this is where your image is formed. Now the eye is here. The eye is here. Actually the eye is much closer to the lens here, but just for the sake of showing it here, we just show the eye here. And so this is your image, this is your object, and this eye is actually very close. So this angle is the angle subtended at the eye by the image. And we know that eye sees best at the least distance of distinct vision. So this distance is d. That means the image distance is d, and this distance is u. So once again, if you see, the object is placed, so the focus is here within the focal length, and the final image is an upright image which is formed such that it is at the least distance of distinct vision from the eye, which eye is supposed to be very close to the lens. Now we also know that before you used a microscope to view this object, you viewed it with a naked eye, and when you viewed it with a naked eye, the eye was here, and the object height is HO. And where did you keep the object to view it the best? Was you kept it at the least distance of distinct vision, so at this distance d. So this is your alpha. So note that for all microscopes, irrespective of whether it's simple or compound, this diagram is always there for the alpha. That is the visual angle subtended at the unaided eye by the object, and the object is placed at the least distance of distinct vision. So now we know that magnification is beta by alpha. Now there is one magnification which we have, and that is, if you note here, I will just highlight this in blue. If you look at this triangle, beta is HO upon U. So we have beta is HO upon U, and alpha is equal to HO upon D. So in this case we have M is beta by alpha. So beta is HO upon U, alpha is HO upon D. So M will be D by U. Now say we use our lens equation, 1 upon f is 1 upon v minus 1 by u. If I multiply both sides, so now this is our generic lens equation, but whenever we want to use this equation, we need to use it with the different distances, keeping their sign convention in mind. So if you look here, v is equal to, now this is your v, this is your image. So I'll just highlight, this is your image, this is your image distance, this is the incident ray, so we are measuring away from the incident ray, so your v is going to be minus d. U will be u, or rather u will be minus u, because our object is here and this distance u is measured in this direction, so u is going to be minus u. So now putting these values here, I get 1 upon f is 1 upon minus d minus u. So I get 1 upon f is 1 upon minus d plus 1 by u. Now our aim is to see if we can get d by u. So say I multiply both sides by d. So d upon f is d upon minus d plus d by u. But this d by u is our magnification m. So we have d by f equal to minus 1 plus m. So magnification is d by f plus 1. So this is an expression for the magnifying power of a simple microscope when the final image is at the near point, as you see here. Now if you recall, for this derivation we took beta, this one, h0 upon u. We took this triangle here, this one, h0 by u. But it is also possible to take this triangle. We can take this triangle here, this triangle which I draw here, where this is hi and this is d, and this is your beta. So this is the derivation given first in the book. M in this case is beta by alpha, but beta, when you take this triangle, this big triangle which is shown here, is hi by d. Hi by d. Alpha we know is h0 by d. So m is beta by alpha, which is hi by d upon ho by d, which is hi by ho. So height of the image upon height of the object, but we know that as being the lateral magnification. So in the case when the final image is at the near point, your angular magnification is equal to the lateral magnification, which is hi by ho. So these are the two derivations that you need to keep in mind.